Let's find out about correlations of different flavor attributes. In other words, we'd like to learn whether whiskeys that score high on, say, sweetness, also score high on the honey attribute. We'll be using the core function to compute correlations across the columns of a data frame. There are many different kinds of correlations, and by default the function uses what is called Pearson correlation, which estimates linear correlations in the data. In other words, if you have measured attributes for two variables, let's call them x and y, the Pearson correlation coefficient between x and y approaches +1 as the points in the xy scatter plot approach a straight upward line. But what is the interpretation of a correlation coefficient in this specific context? A large positive correlation coefficient indicates that the two flavor attributes in question tend to either increase or decrease together. In other words, if one of them has a high score, we would expect the other, on average, also to have a high score. Let's compute the pairwise correlation of columns in our flavors data frame. We start with flavors. We'll be using the data frame function called core. And I'd like to assign the output to a variable called core flavors. We can inspect the elements of the correlation matrix just by printing it. To visualize the correlation matrix, we'll first import the matplotlib library. In this case, I'm going to also specify a new figure. I'd like to get a large figure, in this case 10 by 10. Then I'll use the pseudocolor or pcolor function to plot the contents of the correlation matrix. We can also include a color bar. And finally, we can save this as a PDF. Let's call this core. And then we run this. Let's now look for the plot on the computer. In this case, we're getting a 12 by 12 matrix as expected. Clearly, correlation of any dimension with itself is exactly +1, but other strong correlations exist too. For example, heavy body is associated with smokiness. In contrast, it seems that a floral flavor is the opposite of full body or medicinal notes. We can also look at the correlation among whiskeys across flavors. To do this, we first need to transpose our table. Since these whiskeys are made by different distilleries, we can also think of this as the correlation between different distilleries in terms of the flavor profiles of the whiskeys that they produce. To do this, we can repurpose the code we already have. I'm just going to copy-paste this part here. I'm first going to define a correlation matrix called core whiskey. And we obtain that by using the data frame core function. The input in this case is not going to be flavors, but instead it's transpose. So we turn rows to columns and columns to rows. We'll modify this name here, which is now whiskey. And this is core whiskey. Let's try running our code. And we can then look for the plot on the computer. In this case, what Python is showing us is a 90 by 90 correlation matrix. However, we only have an 86 by 86 correlation matrix. The white space at the top and right-hand side of the plot indicates that there is no data there. I'd like to modify my plot slightly by making the axes tight so that they only cover the range for which I have data. I can do that by using the PLT axes tight function. And we can then rerun the code. And then we can look for the same plot again. And at this point, I'm going to close this because I know that it doesn't update it live. And now we see that the axis ends at 86.